Thank you all so much for coming. Really appreciate the support, and we hope that you leave today with some interesting ideas and hopefully a completely flawless tech demo that happens, with no issues of any kind for a massively multiplayer live deployed game at GDC. So I'd like to just welcome my teammates Rob and Jess as well, and give you just maybe a little bit of background on Improbable for those of you that aren't familiar, just before we dive into the demo. Do we have a clicker? So, hi, my name is Herman, and I'm one of the co-founders of Improbable. We started in a barn in London about 5 years ago, and we had the dream of trying to support you guys building much more sophisticated multiplayer and online games than have been possible previously. In short, what we've built with Spatial is a kind of comprehensive multiplayer solution. It's a platform. It handles deployment for you, infrastructure for you, networking for you, and it plugs into all of the popular engines, Unity, Unreal, and Crytek as well, with a kind of so far semi-official integration that's getting more official by the day. And basically, today, what we want to do is to show you kind of a use case through the utilization of the tech. But just before we do that, maybe a bit more on the company. So last year was pretty big for us. We now support Chinese development as well. So we've built an office in Shanghai. And over the course of the next sort of year and a half or so, if you build a game on Spatial and you have the right permissions, you'll also be able to deploy globally in China as well. In terms of infrastructure, we're starting to support more and more providers. So we had an original relationship with Google, but we're now beginning to support other clouds as well. And when you work with Spatial, you'll be able to port across clouds pretty freely. And the big news, which if you come and check out our Unreal presentation tomorrow, you'll get to meet the head of the studio, is we've just started to build some internal studios too, beginning in Edmonton, Canada, with a bunch of really, really awesome developers who used to work on games like Mass Effect and Dragon Age, and also a new studio starting in London. And the purpose of these studios is really to support our community by building things that can become tools and services on top of Spatial, but also games that can be examples of what is possible with the technology. So we're really excited about that, and it's an open book to any user or partner of Spatial. Come ask us, and we'd love to introduce you to the team and to other key people. So I'd like to show you just a little clip of some of the cool stuff that over the last year folks have been building in Spatial. A whole wave of really cool indie games and experiences. Mavericks, you saw there for a moment, which is a 1,000-player battle royale. Scavengers, which is being built by Josh Holmes and the team who used to work on Halo 4 and 5, which is like a rich arena cooperation experience. King's Hunt, really cool MOBA featuring massive monsters. And one of the things we found is that a lot of people are starting to use us for games that aren't necessarily about big worlds even. They're just looking for a more convenient way to create multiplayer experiences and innovate within that space. So I will hand over to Rob, who will begin the exciting technical direction.
Nice.
Let's clap for Rob. Come on, he's nervous. It's the first time.
Oh. I'm flattered. Hey everyone, I'm Rob. I'm one of the co-founders, and I look after the product suite at Improbable with SpatialOS and our game engine integrations. And over kind of the rest of the talk, we're going to cover a couple of things. So first up, we're going to do an introduction to SpatialOS for those who are kind of new to the technology and what it can do. Second up will be kind of a bit of a review over what's happened in 2018 in terms of technology and the progress we've made there, and a bit of kind of what's going to be happening in the future. And then finally, it's going to be the main event. We're going to do a live demo on stage of developing with the GDK locally. I mean, as a dev, I often find like you can hear conceptually about something, but when you see like real APIs and you actually see what it's like to use inside the engine, it makes like far more sense. And then at the end, we'll kind of do a little demo of something extra special as well. So what is SpatialOS? As kind of Herman says, it's a cloud platform for building multiplayer games. So this is essentially an end-to-end kind of a solution for you to build, do all the networking and hosting of kind of complex online multiplayer games. So what does that mean in practice in terms of the things we do for you? The main big one is hosting. So you don't run your dedicated servers on another provider, you run on us. And we're responsible for the uptime of those deployments when they're running. Another side we're kind of investigating and getting into is online services. So a game, a kind of modern online game, isn't just the game instances running. It's things like matchmaking, authentication, persistent player data. All these things need to kind of work in perfect harmony, and any one of them, if they break, you have a bad time for your game. We're trying to get involved there as well. Tools are a really important element. It's one thing to be the place you run games and be the kind of tool to be able to do more, but you need to kind of have the internal tool set to actually explore that capability. So we have a whole suite of observability tools from like metrics, logging, and a really cool thing called the inspector, which I want to show you later as well. And that's a really big part of what we're trying to do here is make it easier to build innovative games, not just give you a bigger box, help you like leverage that bigger box. And then the final thing, which is something we've talked about a lot in years past, is our kind of unique networking stack, our runtime. And that's really the kind of core piece of technology that lets you do the kind of crazy things we've been talking about over years in terms of new types of game experience. So let's dig into that one a little bit more, because that's something worth kind of talking about. So on the kind of left-hand side here, you have the architecture of most games you probably play. So from Battlefield to Apex to PUBG to Fortnite, any high-fidelity online game normally consists of a dedicated server on the server side, which is kind of running a version of your game engine, and then you have clients connecting into that. So in the case of Unity, you'd be building Unity, probably headless Linux on the back end, and you'd have clients connecting in with whatever you want. So this is great if you want to do kind of smaller high-fidelity experiences. You want to play 32, 64 players. If you look at kind of the battle royale genre, they've already kind of dialed that up as far as it can get with 100 or so players there, and they've had to make some sacrifices to do that. But if you want to go beyond that, if you want to kind of say add to that game world something like persistent AI, or you wanted to add physical destruction or increase the player count, you're kind of at a cliff edge in terms of the power of what a single server can do. So Spatial is on the right side. It's kind of a rethink of this. So you still have clients, which are game engines. You still have servers that are the same game engines But rather than there being one dedicated server simulating a game instance, you actually have many of them, which can all cooperate together and simulate a game world much bigger than any single one could ever deal with. So how does that work? Because that sounds kind of crazy. So this is kind of more of a kind of infrastructural view of what's going on. So you can see, you still have clients, you still have servers, which are kind of, in the case of Unity dedicated servers and clients. But they've both integrated our SDK, which gives them a networking capability. And the clients, rather than connecting directly to servers, like normally happens, they connect to a piece of technology which runs kind of nearby the servers called our runtime. So this runtime is a distributed system. So it's not just a single server running something. It's actually a fleet of machines that cooperate together. And because this is a distributed system, it can handle far more clients connecting into it. And then next, the servers, rather than the servers having clients directly connect to them, they actually connect into the runtime itself. So the kind of consequence of that is you can have multiple game engines connected into the same instance. And then from the client side, you can be finding out a lot more messages. So that poor server in the previous slide had to do all of the networking and all the message sending. For us, that's our runtime, which is doing all that heavy lifting. So we talked a ton about the kind of crazy, massive game worlds we've always dreamed of people making. And in the early days of the company, that's what we were really kind of thinking about. But as we've kind of started to work with more companies, we've realized that SpatialOS is just a really convenient paradigm to make games. And you don't really have to dial everything up to 11 to make use of it. It's really about you kind of exploring with your game. You've now got this bigger box, but it's up to you to explore that box and kind of see what you want to do with it or not do with it. Maybe you want to start to innovate incrementally and start to maybe add more players or add AI when you normally didn't have the budget to do so. So to kind of break that down, scale. You might want to have a large social hub in your game world that has 1,000 players interacting and buying and selling goods before matches. But the matches themselves might be just traditional battle royales with 100 players, or more of a kind of PvE experience with like 4 players. That's totally fine. You can mix and match these different things. It's just a totally scalable paradigm. In terms of simulation complexity, we talk about massive physical destruction and AI kind of swarming around. You can do that if you want to kind of build games with those experiences. But equally, if you want to do a more traditional PvP shooter, doing just server hit validation and player movement, you can do that as well. And then persistence, this idea of a game instance lasting for months or even years at a time and having a history and a state. You can have parts of your game that are persistent, so you could have a persistent environment where players can like conquer territory and own things, but there's nothing stopping you also using SpatialOS for the transient instances, or if you want to make a more traditional session-based experience. So the kind of takeaway here is more about like flexibility. You have that big box, but you don't have to use everything around that big box. So that was kind of a bit of an overview of what SpatialOS is as a tech. Next up, I'll give you a review of like what we've been up to and some of the cool stuff we've been working on. So this is kind of one of my favorite pieces. 2018 was a year we finally kind of had real production games hitting players and kind of really kind of going live. And it was a really good opportunity to reflect on the technology, and we've been kind of working with those partners very closely to make those games possible. We started to think about what was next, though. So the types of games we were hitting, so you saw 2017, about 1,000 players in the same environment, we were kind of getting there. But we wanted to think about scalability, going back to the previous thing. What would it be like to have a technology that can scale all the way up to 10,000 players and beyond? And equally, what would it be like to have a technology that can scale down to 10 players, still having the same tech? You don't have to use like different solutions for different things. And we undertook this kind of Kraken project, which is to redesign our system around kind of arbitrary horizontal scalability. So where are we getting on with that? I'll kind of introduce some vocab called ops. Ops is our way of thinking about the complexity of a simulation. So a write op is when anything in the world changes. So if a player moves and AI kind of like does something, that's a write op. And then you have read ops, which is whenever something happens in the world, somebody observes it. That's kind of, say, if you moved and 10 people were watching you, then there'd be 10 read ops generated and 1 write op. So kind of up there, you can see the kind of operations per second. So a 1,000 player MMO, about 250,000 ops per second, we got back in the day. With kind of some of the benchmarks we're doing with our new Kraken runtime, we're kind of pushing towards about 6 million operations a second, and this is just a start. We have a raft of optimizations coming in. So what this really means is, I guess in terms of some concrete examples, you can have action games we think to kind of get to about 5,000, 6,000 players of super high fidelity combat. Or if you lower down the fidelity of the simulation, you can always go bigger. So from that side, that kind of translates to about 20,000 players in an MMORPG scenario. And as I said, this is just the beginning, but it's just kind of showing that, I hope next time here in 2019, we're going to need a wider slide with bigger graphs. So, it's one thing to build that bigger box, but another thing we've been investigating is tools to help you understand what's going on inside that big box. And one of the things which I've just been super psyched to see is our new inspector, which is essentially a kind of kit which lets you assemble like sort of querying and debugging tools to inspect the data of your game world in real time. So this is actually a real world simulation going on. It could be even a production game if you wanted. And you can see the position of every player, every AI, inspect every piece of state, chop and change the world, look at it in a tabular way, visualize it in many different pieces. And this kind of shows as well, we're not just investing in the core capability of the system. It's also about these kind of unique challenges. If you want to make these big games, you've got other challenges you have to resolve as well. Another kind of exciting part of the Kraken project was a feature called query-based interest. So for those of you who might be familiar, when you have a game world which starts to get to kind of tens or about 100 people in size, there's a really complex task of working out what everybody needs to see, because everybody can't see everything because they'll get super overloaded and you'll be sending too much data. Query-based interest is a kind of our approach to do that. Traditionally, if you look at an MMO, normally as a player moves around, you actually have like a bubble that follows you, and within a certain distance, you'll see things, and anything further away, you don't really ever see, or you have to do like really kind of special hacks to make that work. Query-based interest is our kind of API, which lets you declare exactly what you want to see in your game world, at what fidelity, at what distance. So you might have, sort of in a high fidelity environment, you're running around, and everybody near you, you're getting updates 30 times a second. Further away from that, you're getting updates, say, 10 times a second for a couple of 100 meters. But maybe in the distance, every explosion you see, they don't happen very often. You want to receive any explosion no matter where you are in the world. You can declare that as well. And this can change dynamically. So maybe you're on the top of a hill and you get out a telescope and you see a tree in the distance. And maybe that tree actually has like individual apples on that tree, which are entities. Like this is all possible with this system, which is like super exciting. And it's something where you're not sitting there coding it all yourself. It's almost like a SQL-like language to define what you want to see and when. Another thing we've been starting to explore is online services. So a lot of what I talked about right now is the game instances themselves, right? It's the actual session which people connect into and play. But games aren't just that anymore, especially games as a service. There's so much other things you have to think about, from like matchmaking, persistent player data, inventories, analytics, all these different things. But you don't really have like many instances of those things. You tend to have like single, highly available services to do that. And we've kind of had working with some partners, and they've been kind of building their own stuff or working with third parties. And we thought this is kind of a next area we want to be getting into. So what we're going to be doing over 2019 is actually 2 things. The first one is giving an environment to build these types of services, which integrates really nicely with SpatialOS. So if you want to make a service that's going to be able to store like the inventory of characters, which persists as you go from deployment to deployment, or from your social hub to your next session, you can have a place where you can write that code to kind of interact with backend databases. And beyond that kind of compute environment, we're going to be giving you services as source code, which you can deploy in that environment to start playing with. So things like matchmaking, player auth, player profiles, inventories, persistent data, that type of stuff. So it's very similar to with SpatialOS. We gave you a very low-level abstraction and then libraries on top to modify. And the entire thing's API first. So you're going to be able to rip out and modify everything you want. If you want to use a third party for your matchmaking, but you don't for your persistent data, you can kind of mix and match. And it's all about that flexibility. So time for the main event. So the GDK for Unity stands for Game Development Kit. So SpatialOS is a really awesome kind of technology in terms of capability, but we were kind of thinking about our integration with Unity, and we kind of wanted to rethink it around solving the actual game development challenges of making a game, which is multiplayer using Unity. And that goes far beyond just plugging into our networking stack. It's a whole tool set. It's a whole like day-to-day experience to make it like really, really badass to develop day-to-day. So in terms of what you can get, like we kind of architected the entire thing to have like as minimal allocations as possible. The whole day-to-day experience of using it, it's like super fast. When you see the demo now, you'd never have to rebuild out players. The entire thing is actually running within the single editor at the same time. And then the final thing is really gameplay out of the box. So architecturally, if you look at this, we have a core, which is essentially like a networking library for Unity, which you can kind of plug in, similar to kind of other networking libraries out there. But on top of that, you have the kind of feature modules, which are a lot of common problems we know are they're really hard to make. And we've built them as open source pieces of content you can just drop in and use. So when you kind of see this demo now, things like client-side prediction, character movement, shooting, like a lot of these things are difficult challenges and there's a lot of complex algorithms involved. We have that stuff kind of to give to you out of the box. And then on top of that, you can build your game. And beneath this, obviously, is SpatialOS. So although these are very familiar APIs, under the hood, you're actually leveraging kind of all this computational horsepower. You can have, not just one server, but as many as you want. So yeah, let's kick on with the main event. So I kind of invite Jess to kind of start having a chat and running us through the Unity GDK project.
Thanks, Rob. Before we get started with the actual live demo, let's take a look at the different SpatialOS concepts that we're actually going to use in a live demo and when you're using SpatialOS in general. So first of all, we have something called workers. Workers are nothing but your client or server instances, whatever you want to execute, any kind of logic that you want to execute on your server or your client side. These workers connect to deployments. A deployment is your game instance that allows you to connect to different clients and server instances to it. And SpatialOS is also aware of the current state of the deployment, the current state of your game. Any kind of object that needs to be synchronized is going to be stored inside this deployment. These objects that are inside the deployment or your game are also called entities in SpatialOS. So any entity that you're going to need to synchronize between different workers will be in there. And each entity may store data on them. If you think about a player, for example, a player might have a health data that you need to update accordingly, and these data will be stored inside components that you can add to your entity when you create them. Lastly, so that you can actually communicate between the different workers, we have events and commands. So an event, you can think of an event as a broadcasting message. One worker can send it to multiple other workers to let them know if something happened, while a command is something that one worker would send to one other specific worker. This is just a very short introduction to the different concepts that we use, and we now are gonna start actually take a look at our FPS data project that we have in Unity. So I've already opened Unity, and our FPS data project that is available on GitHub uses the GDK for Unity by making use of the Unity package manager. So our GDK is structured in has multiple packages that allow you to add multiple gameplay features or tooling that you need for your game, and you can decide on your own which packages you actually want. If you take look at an example, for example, the SpatialOS GDK core is something that you will definitely need. It's the part that will take care of the synchronization with SpatialOS, make sure that you send and receive the data. We also have, for example, a game object creation module that allows you to create game objects from your SpatialOS entities and visualize them accordingly, however you want in your scene. Other modules would be like something like health or guns, different gameplay modules that you maybe want to add, or maybe you want to create your own gameplay out of it and create your own logic. So it really depends on your game what you want to do. We also provide you with a SpatialOS menu, so it allows you to quickly get started. It allows you to build out your workers inside Unity, add some configuration that you might need for SpatialOS. And also what we're going to do right now is you can also start a local deployment. So if I click on local launch, it will start a local deployment on your machine. You don't need to build out anything. You don't need to connect to the internet to actually start it up. It will just do it all locally on your machine to actually allow you to iterate really, really fast. While that's starting up, let's take a look at how we structure workers inside our GDK for Unity. So we have multiple scenes. For each scene is a worker in our case. So we have, for example, a client scene, we have a game logic scene. You can add game objects that you need in there for your server or your client instance. And also we have a development scene. This scene actually contains multiple workers. So the way we add workers to a scene is by adding game objects. For example, we have a game logic worker here in our development scene, and a client worker, a simulated player coordinator. This one actually spins up simulated players so that you can test with them and see how it works. Each game object actually also has a mono behavior on them, a worker connector. It just contains all the connection logic needed so that you can connect to SpatialOS. Now, if we take a quick look, we see that SpatialOS has started up, so we can actually start our development scene and just see how it looks like. And as Rob already mentioned before, we have an inspector. If you take a look at them, it allows you to actually look at your current SpatialOS view, how SpatialOS views the world for a local or cloud deployment. So here we can see how there are 2 players already running around. These are the simulated players that we start up. We see what kind of workers are connected. So you can get a really quick overview of what is currently happening in SpatialOS. Now, if we go back and just start connecting, we can see the players already shooting me.
Nice. So just to recap what we've seen there, and this is what the kind of local iteration and local development experience is like. So you have Unity up as normal, but you have our SDK kind of like sort of integrated into that. And then when you're deving, you run SpatialOS locally. So that's running like a local network stack, which is going to store kind of all that persistent data and do kind of networking. And when Jess pressed play there, it didn't just connect in a client, it actually also connected in a server at the same time. So this is kind of one of the big things to talk about is just the idea of being able to play within the editor as clients and servers at the same time, which really is useful for day-to-day debugging, and also means you don't have to build out any players, which can take a ton of time if you start to have a bigger project. So next up, we're going to run through, this is a nice kind of slice through kind of the iteration cycle, but let's run through kind of a code example of what it's like to actually implement a gameplay feature using it.
Sure. So as you've maybe already seen in the left top corner, we have a health bar that's actually not updating right now. So we're going to add the logic to let it update it accordingly. So if we stop the scene, before we go to our C# project in Unity, let's actually talk a bit about how data gets represented in SpatialOS. How do we make sure that all the workers can communicate with each other, and SpatialOS is also aware of the data that we have. For that, we have something called schema. A schema simply contains some kind of namespace. You can add other schemas. And what you do in there is you can define types that you may want to use for your components that you then actually define in here and can add to your entities. This example, we have a health component, which we already added to our player entities. Each health component contains 2 fields, a health, the current health that we have and that we may want to modify whenever we got shot or when the health regenerates, and a maximum health. We also can define some commands and events here so that we can notify other workers when something changed according to the health. So this schema does live outside of Unity because it is actually engine agnostic, so you can use it for your Unreal integration for Unity for workers that don't actually use any kind of engine but are just pure C# or C++. For that reason, it lives outside of Unity and is not tightly linked to the GDK for Unity. However, we do provide an integration with it and make sure that you actually don't have to provide any kind of C# conversion to it. But we provide here with the SpatialOS menu a generate code button that will generate everything that you need to actually use the schema inside your C# project. Now, if we take a look at our C# project, we have a health bar handler here, which is added to our player prefab, and it contains a method called setHealthBar, which will change the visualization of the health bar depending on the fraction of health that is left. Right now, it doesn't do anything. setHealthBar is not called. To make sure that we actually receive the data from SpatialOS and the GDK is aware that this mono behavior needs to know data from SpatialOS, we're going to add the following attribute. It's called require. This simply tells the GDK that it needs to make sure that this mono behavior knows about certain types of SpatialOS data that we might need. In this case, it is the health component reader. So we generate 2 types of objects formal schema. One is the reader and the other one is the writer. A reader simply allows you to read the data, in this case the health component data, or react to changes or whenever the health changes, while the writer allows you exactly the same and also to actually modify it. So it's something that you would like to use on your server side when you actually modify it when you get shot, for example. So if you write this, the GDK for Unity will make sure that the object is available as soon as this wonderful behavior gets enabled. So when onEnable is called, we know that the health reader is already available and we can use it. So what we can do is we can actually register and listen to whenever the health gets updated by registering this method that we're going to create now to it. So internally, the GDK is listening to SpatialOS all the time and making sure that it knows whenever something changes and can also react to it. And then it will call the different methods in the mono behaviors wherever we need it to make sure that you can actually execute the user logic that you want. So now with this onHalf update method, we also pass in the new half that we have for the entity. And all we need to do is compute a fraction and then divide it by the maximum half that we can read from, that is the wrong one, that we can read from the health reader. And then simply call setHealthBar. Now that's all we need to do to actually visualize the health bar and make sure it's up to date with whatever SpatialOS perceives as the current view. So if we go back to our Unity project, we just need to wait until Unity re-imports the script. And as soon as this is done, we can go back to our scene and actually start it up. Note that during all this time, we actually never stopped Spatial. So SpatialOS is still running in the background. It realizes when any worker is disconnecting or connecting. And now we can connect in. And the health bar should get updated, yeah.
Hey, good stuff. So yeah, well, what did we just see there? We saw what it's like to add a kind of piece of gameplay functionality using the GDK. So the first thing is schema, which is kind of our way of defining the persistent data and the synchronized data of your multiplayer game. And then from that, the GDK generates kind of really nice idiomatic Unity code, which you can kind of access from mono behaviors, which lets you read and write data, which is actually coming from the networking stack. And you can see you can plumb that into health bars, but you could equally use that to visualize whatever you want. And yeah, this is something worth reinforcing. Like all the while, we haven't built anything out yet. We've been adding new gameplay features. We've been adding kind of like sort of new functionality, and you just hit play, and you can continue playing. And for those who've kind of like built multiplayer games with Unity before, this is a really big improvement to iteration and workflow. It's pretty much like building a single player game. It's super awesome. So this is all about like developing day-to-day locally, but the end of the day comes and you want to be able to actually do a larger cloud deployment. You want to actually have something running which people in your studio can connect into and play and test it out, or you want to kind of give it out to your family and friends. And with that, you can use our kind of cloud hosting and deployment stuff. And that's what we'll be doing next, is actually getting it in the cloud. In terms of scale, we're going to be scaling it up to 200 players. This is kind of beyond what you can do with just Unity on its own, but it's kind of also what anybody right now, if you were to download the GDK, you could do yourself. If you want to go bigger, you can just get in touch with us and you can get the quota to do larger deployments.
Yeah, so if we stop the scene. So if you want to use your cloud deployment, then you actually have to build out the workers. So what we would do is we go to SpatialOS, build for cloud, and then you can just build out all the workers. We've already done it for this demo, so we can just go to the next step, which is opening the deployment launcher window. This window allows you to upload everything to the cloud, make sure everything is running. The first part is we would upload an assembly. An assembly contains all your build-out workers and any additional configuration needed to actually start your cloud deployment. While the second part is actually starting it up, so making sure everything is running. We've already done this. So if we go back to Google Chrome, we can see our deployment overview page here. So this is an overview of what is currently happening with your cloud deployment. As you can see, it is running. We see the different logs types that are currently happening or what has been logged so far. We can see what kind of workers are connected. So as you can see, already 200 Unity clients are connected. These are the simulated players that we're going to see later on. Also, you get access to all the other advanced configurations that you might want to use. For now, let's take a look at the logs page. The logs page contains all the logs that either SpatialOS or the different workers send to SpatialOS, so you can debug whatever is currently happening. You can see whether any errors or exceptions have been happening. So here there have been a lot of logs about the simulator players connecting in. If you want to filter for anything, so if you think a certain worker, for example, or entity has been going wrong, something has been happening, you can use this sidebar here where you have either you can filter for a message, for some kind of log level, or for the worker entity ID, which is really, really useful to actually debug when something goes wrong. The second page that I want to show you is the metrics page. The metrics page allows you to learn a bit more about the actual networking that is happening on your deployment. So is the deployment healthy? Have there been any errors? How many workers are currently connecting in? So if you take a look, currently no errors have been happening. There are a lot of workers connecting. The overall latency that are for the different workers. And there's a dashboard over here that you can also use to gain more knowledge about like different commands, events, what has been sent, what has been happening. Lastly, we have the Worlds tab here. So you can see it looks just as before. This is our inspector. So if we have an inspector for your local deployment and your cloud deployment, and if we zoom out a bit, we will see that, oh, that was a bit too far, that there are a lot of simulated players running around here and shooting at each other. So you can see all the workers that are connected, everything that is happening here. And that is all that I wanted to show you about the deployment page and what we provide you with for cloud deployments. So what we can do now is actually connect in ourselves. And while they're starting up, so we have two buttons here. One is the launch button, which I just used, which allows you to download the client yourself and get started really quickly to see what is happening inside your deployment. While the other button is a share button that will generate a URL for you so that you can actually share it with friends or people that you just want to do a play test with. So if you start this up, it will look similar to before by starting the start screen, and then we can connect in and should see some of the simulated players around us. Yeah, there are a lot of them here shooting at each other, running around.
Nice. So yeah, just to recap what we saw there, you saw the integrated toolset of the GDK, which lets you build out the kind of like server and client for your game in a way which can be uploaded to our cloud platform. And then from there, we had a cloud deployment running that actually was using more scale with what was going on in the cloud. But you saw as well, a lot of the tools which Jess was using in the cloud are exactly the same as the ones you use for local day-to-day dev. The whole point is it's meant to be just a very seamless and consistent experience. This launcher is really, really useful. Like when you're kind of like messing around with a build and you come up with a new idea, you can just like dump a link to this kind of launcher in Slack to your kind of teammates. They can log in, they can like sort of check it out really, really quickly. It's just kind of saves the pain of having to like distribute files around. The other thing as well, which is worth kind of looking at, is these aren't AI in the sense of NPCs running around the world. The way this is architected is these are kind of simulated players logging in and acting as real players, exerting the same load on the system that a real player would. And what we kind of noticed is when people were making bigger and bigger games, you reach this critical point where you actually have game worlds with an instance size bigger than anyone in your studio in terms of total. So how do you do a play session? You have to kind of have some way of automating that, some way of kind of exercising the scale before you're able to kind of get real people involved. So often we'll have studios running simulated players on their CI and build on a daily basis and kind of making sure that they kind of see what's going on here. And yeah, in terms of scale, this is about 200 players logged into a session in about 4 instances of Unity working together. But again, with larger quota and scale, you can go much larger than this. And that box is pretty much as big as you want to be. It's more what you want to do inside of it. So to kind of wrap up from the demo, one of the things we've been getting a lot of requests about is mobile. We've shown games on PC, we've shown games kind of coming to consoles, but mobile is a platform which we've been really excited to see these types of high fidelity experiences coming to. And we've been doing a bit of tech work under the hood to make that possible. So one is kind of actual mobile build support for iOS and Android, so you can link in the SpatialOS SDK into it. And the other one is mobile networking. So obviously 3G networks and 4G networks are very unique compared to Wi-Fi and wide connections. And we were kind of integrating a network protocol called KCP, which is designed specifically for mobile networking, and we have that integrated right now. So this is, we're going to do the even more scary part of the demo, which is try and do a live demo of me playing on a mobile phone. So I think we do this.
Yeah,
With GDC's internet connection and Wi-Fi.
Oh, yeah, this is going to be great. Success guaranteed. Is this my hand? This is my hand. Oh, God, that's too zoomed in. That's crazy. Let's see. Come on. So when I connect in now, I'm going to be connecting into the same deployment Jess is actually inside of. So cross-plays kind of just comes out of the box for free with our networking stack. And yes, there we have it. It's all working together. I'm not going to play very much because you realize how much I suck at touch controls on phones. But you can see kind of it's all kind of integrated together.
Cool. Very nice.
Nice. Before I hand up kind of back to Herman and close things out and then get some time for questions, I just want to really reinforce like this exact experience we went through. We've kind of gone through this now because you can do this right now. You can like go on your laptops, download this, and run this exact deployment as part of our kind of Unity starter project. And also on the mobile side, if you're interested in working on a mobile project, we're ready to be doing early collaborations. So come to our booth if you're interested and you have a mobile title in mind you want to collaborate on. All right, thanks.
Awesome. Thank you so much. And thank you so much, Jess and Rob, for a nerve-wracking live demo that you pulled off really, really well. It's awesome. Very cool. So I wanted to cover a couple of quick and I think really important areas just as we close off. The first is the commercial side of this, right? So you're all looking at this thinking, you know, that seems pretty good, but is there like some secret catch here as to how we're going to charge and how you're going to end up working with us? Well, I wanted to give you a rough idea of what our model will be, which we'll be making public later in the year. So the thing to understand about us is that we're effectively just another infrastructure provider. So the way we can operate, we become a sort of virtual infrastructure provider that you build on top of, and we in turn can then provision service for you for wherever you'd like to go, whether that's Amazon, Google, anything. We choose that for you at the moment, but for some of our larger customers, they have specific requirements, we're able to do that as well. And the power of that is that the cost for developers, particularly indie developers, if you think about how this works, goes down and down and down, because we're able to aggregate one giant spend across the cloud that represents all of our customers and our larger partners. So when our prices go live, you're going to start to see how it's really cool for you because you're able to get a price even on underlying infrastructure that you might never have been able to get without a large commitment of spend. So we're hoping to give you not just the ability to innovate technically, but the ability to innovate commercially as well. Another thing I wanted to talk about is kind of like, why us as a partner? You know, why do this with us versus other approaches that you could take, building it yourself, doing it in a different way? And I think what we've tried to become over the last 5 years is more than just a service that's a black box, but more of like an industry partner with an infrastructure focus that can start to do things that really enhances your own innovation. So a good example of this is our open source work. A lot of the under the hood pieces that make SpatialOS possible are new approaches to very large distributed systems, from new research that we've published to new open source tools like Thanos, for example, which is a really cool open source framework on the infrastructure side. It's being used by Google and Microsoft as well. So we're trying to be kind of leaders in the adoption of new, clever, cloud-first technology and to create a layer that allows you to kind of go further. And I want to touch another point too, which is if you're going to go be an amazing, successful game developer, what's becoming clearer and clearer is that it's not okay to not have any tech strategy of your own. You know, there are so many more convenient tools and platforms out there than ever before, but if you're going to build something differentiated, you're going to want to innovate. Maybe you have a cool idea for distributed AI. Maybe you have a game engine in mind that you want to go and make. Maybe you have some tool no one's even thought of. The power of what we're trying to do with Spatial is to go API first, low level, and allow you to build those things, and if you want to, even sell those things. And what's been so exciting for us is watching the innovation our community started to do. You know, with our Crytek integration, that was just done by a customer that actually built their own integration into SpatialOS. So another final point I'd make is that we're not trying to be a closed black box company that is just going to show up and show you things. We want to work with you. We want to be your partners. Our Discord's live, and our community is kind of, it's in that nascent stage where people are like super enthusiastic. So come join. People are very helpful. And if you're ever in London, come pay us a visit as well, or Shanghai too, our other hub. So thank you all very, very, very much. And if you're interested in Unreal and you'd like to see a very different style of integration for the Unreal Engine, which is much more focused on leveraging Unreal's kind of native gameplay, come see that tomorrow. And you'll also get a chance to talk to some of our internal studios and customers as well. So we have some time for questions. And then after that, we will sail off into the sunset.
Hello. Oh, cool. That was loud.
Please, troll questions only. No normal questions. We don't like that.
So if you could just put your hand up, I'll come around with the mic so everyone can hear.
Final point, VR-ready stuff works very similar to mobile and PC. So whatever crazy device people come up with next week or beyond, you'll be able to integrate that with spatial as well.
Hi. So you are using ECS in your SpatialOS, but what about Unity ECS, which was announced by Unity? You will be change your ECS on Unity to get performance benefits from burst compiler and other stuff from Unity.
Yeah, so we are using the Unity ECS under the hood, and we are also trying out the burst compiler right now. So we haven't integrated it completely yet because it actually doesn't support Linux as far as I know right now for 2.18.3. So, but as soon as it does, we actually want to make sure that we have as many performance gains as we get from the Unity ECS.
Thank you.
Also, bear in mind that our GDKs are all MIT licensed. So you can literally change that yourself if you want to and fork it and challenge us in the open source domain at your own peril.
Yeah, it's worth mentioning, we use the ECS under the hood. So there's two APIs. There's an ECS-centric API if that's your jam. But then we also have a monobehavior API if you're kind of more used to that way of coding, and you can kind of mix and match within the same project.
We have customers that don't use our Unity integration because they started before it.
That was a really great demo. Thanks for showing that. Question about the generate code button that you had. So you take the schema and you generate model behaviors or ECS components, I'm assuming. Do you provide source code for that?
Yeah, it's all open source on GitHub, so you can just check it out and change it if you don't like what we currently have.
Cool, thank you.
It's a really key theme over and over again. Like, so many people provide tools and services that are black boxes, and it's so annoying when, as a game developer, you need to modify things. So we've just tried to take this view that it's all API first, it's all open source wherever it can be. Yep.
Hi, can you address the licensing kerfuffle?
So I will, in fact, do that. And I'm off. I would like you all to know I'm off to go see Unity straight after this meeting. So we're all friends. It's wonderful. Sometimes the internet can overblow things. And if anyone here created the Star Wars parody for that licensing dispute, I'd like to personally thank you, because that was one of the best things I've ever seen in my life. But anyway, the issue that occurred with Unity was really, in the end, a big misunderstanding. And it boiled down to the fact that all we are really is an infrastructure provider. The analogy that I would use is we're like a car park. And so a Volkswagen might park in our car park when you upload a Unity instance. We actually, other than the fact that we provide an open source integration with Unity, there's no Unity-specific source stuff or anything like that involved in SpatialOS, which is generic. I think in our misunderstanding, that wasn't clear to Unity, and it wasn't necessarily clearly explained in our interactions with them on both sides. Once that was clarified, we're in a much better position. Also, their terms of service change was a bit blanket, covered us and a bunch of other people. And I think they've been really magnanimous, and they've rolled that back, which is amazing. So as far as we're now aware, thanks to a very interesting week where Rob apparently did not sleep for 2 days, we have gotten every major engine provider, Epic, CryEngine, and Unity, to all publicly state that they will never charge for similar things to the ones that operate in our dispute, that they support services like us and others forever. So basically, we're in a world now where you as a developer, you can build with whatever engine you want, you can use Spatial or not, or anything else. And we are committed also to a very open ecosystem. So we're very complementary with streaming services, for example. You might have seen us on the slide with Google. We're very open to however you want to mix and match and build things. And we love Unity. We have T-shirts that say we work with Unity as well. So yeah.
Hi there.
Hey.
Does your demo that you have presented there, or your sample project, does it have the physics sync?
Sorry, could you say it again?
Physics. Does it do physics? Do you have any
Oh, do we have physics in that?
physics
I can
on the network? Yeah.
focus on.
Like player physics specifically?
Sure. Player physics and distributed physics may be worth a brief.
Yeah, we just use the normal physics that Unity provides us with. So we are actually not doing anything special right now. We do have a movement package that makes sure that everything is working distributed-wise.
Yeah, so the movement package there is allowing you to kind of have a client be observing kind of physical objects moving on the server side and see that really smoothly, which is pretty challenging to do. And then also the migration of a physical object from one server instance to another one as well.
You can actually build, if you wanted to, a custom distributed physics solution using the low-level pieces of Spatial, so you can decide what it means for engines to overlap, how they interact. If someone does that and open sources it, we'll give you infinite beer. So
PhysX is open source now, right?
Thanks.
What's the process for like integrating into a completely custom engine, like not one of the popularly available?
So I can talk about commercially and then maybe technically.
Yeah,
yeah. So you're obviously free to do whatever you'd like to do. If your game project's interesting and you'd like to partner with us, or we actually have a dedicated production team. So we're quite unusual among tech companies in that we have actual games producers and tech directors with years of experience who sit in a dedicated production team. All they do is have conversations like this, and they can give you advice on how to do the integration, or they can actually do it with you or for you, which we've done for some of the more prominent publishers out there at their command. But maybe, Rob, you can talk a bit about the technical details there.
Yeah, so with bringing your own engine, we have this really nice low-level C API, which is like the least opinionated thing ever, right? It's designed to have like thread affinity, custom memory allocators. It's like all the good, fun, hardy stuff you want when you're kind of integrating with your own piece of technology. And from that side, you integrate that into your client and into your server. And then you, we have some examples, but you essentially build a code generation layer that maps like your data model from your game into SpatialOS's data model and can kind of go back and forth. And then when you're there, you can kind of then compile out your server as a kind of Linux executable that runs in our infrastructure. And then happy days, you're going. So the SpatialOS library is just kind of like a networking library, but then you can leverage this infrastructure.
What gets pretty interesting is if you try and build an engine around it to start with, and thinking about how that would work is pretty cool. One of the things I'd add just to get to know each other a bit more is if you look at our C API and the documentation around how we operate, you kind of get a sense of how we are as engineers. So we'll always start at the bottom of the house. So the APIs, the basic stuff will be thought through endlessly, like does this create race conditions? We've done research to like create things to try and prove things don't have race conditions. Where we're weakest is probably in our journey as a company, as you go higher and higher up the stack to things like tools and features like this GDK only was invented last year. So from the outside in, we can look like not that fully featured, but really what we've built is this infrastructure that's just designed to get it right from the beginning. And you see this with performance as well. So things like horizontal scalability and being able to have a very large, predictable system is what we focus on. The optimizations to then just grind out performance from that are actually quite straightforward on top and more game specific. And so we can work with you to do more and more of that. Lots of healthy questions and not a single troll question, which I have to say is disappointing.
Hello.
Hey.
You'd mentioned that you can deploy into China. Do you have any details on the infrastructure providers you use there or who you work with?
Sure. What we can say publicly right now is that NetEase is a partner and investor. We're not exclusively in any way tied to NetEase, but what we're doing at the moment is we have a solution that uses local cloud providers will allow you to basically deploy there. We're currently deciding on which providers we'd like to double down on and focus on and work with publicly. But as you know, Amazon operate in China, so do Microsoft, and so there are a lot of very straightforward possibilities. The main advantage for you is that you don't think about this after you've deployed on Spatial. Like you've done this in direction so that you never have to deal with that problem again.
Probably got time for a couple more questions.
Maybe we'll go with three more questions, and then you can mob us afterwards, and we'll do autographs because it's so exciting. No, maybe not. If you want a SpatialOS or Improbable t-shirt, by the way, you can come get one.
Hi. I was just wondering if you guys had anything further, because you were on the Stadia slide yesterday with all the partners and everything, if you had any sort of things to announce for that.
We could talk about just how that would work.
Okay, sure.
But I can't go into any details beyond anything that's been public, but I can talk a little bit about the structure.
I can do a bit of the tech side as well.
Sure, yeah. I mean, what I'd say is like streaming in general, for those of you that are not familiar, is basically taking the client and moving that onto the server. Now, in principle, that changes nothing. In fact, you can use everything we've just shown you with that, and now don't have to write client-side prediction code. Now you don't have to worry about latency between clients. Now you can do all kinds of fun stuff on top of that. And actually, the example I always like to use is like the Battle of Minas Tirith, right? Like, if you wanted to do that battle, you'd have to deal with two problems. One is, yes, the distributed server-side side, which, hey, we got you covered, even at the scale we're at now. The other side would be, well, how do I do all the cloud rendering and stuff for my clients so that I can actually witness all of that without having 700 Xboxes locally all in some kind of super cluster? And streaming solves that problem. Yep. So the two things work beautifully together. We're not tied in an exclusive way to Google. So if other streaming services come up, you can work with them too. But because we're on Google Cloud now, it's a pretty good solution.
I think that's a really exciting side of streaming is one of the things you actually come into as a limit when you're trying to build these really amazing games and going large is actually bandwidth more than anything else. It's like you just have that finite bandwidth down to the client and you want to be kind of limiting that. And going back to the Battle of Minas Tirith example, when you have that many goddamn orcs, you're gonna have so much bandwidth to send it down. And there becomes a point where it's cheaper to send a video feed down to you of the orcs than send you down the actual position data of all those orcs. And when that happens, you kind of flip around, you can start to make insane experiences. So I think seeing distributed compute like this mixed with server-side rendering is gonna be insane.
If you also want to take a wait-and-see approach to streaming, Spatial is pretty cool, because when you're on Spatial, whichever streaming service you decide to go with, you're not going to have to make extensive modifications to go with them, because you're already on a networking paradigm and abstraction. Another point to mention is Google mentioned a few times things like big physics and things like that. They were kind of referring to services like this that become more viable in that context. Cool.
Anyone else? Time for a couple more?
You got
yep.
one there.
Hi again. You
Could you introduce yourself and your hometown? No.
the things like client-side prediction and like the frequency of updates and that sort of thing. You didn't show that in the demo, but is that easy to configure and set up? Is that through the schema, or is that through something else?
Yes, so that's like that's where the feature modules come in. So SpatialOS itself on a low level doesn't really know what those things are. It really is just like a data networking system. So things like CSP, the feature modules, which kind of just as kind of when you're running around with the character, that's kind of what we were using. You have full source code for that. So you can have a fiddle around, and you can see what's going on, and then how you are interested in like what you see in the game world as you move through as well. There's APIs in the GDK which you can hook into, and from the inspector as well, you can actually visualize what's going on there. So that's completely exposed and completely open to you. Something where we found actually we can't have an opinion. We can give you a great starting point, and we can give you the code to kind of continue.
One of the nice things is you can change authority on objects really seamlessly. So that applies to the client as well as the inter-server stuff. So you can do things like if you're playing a VR game and you want a very sophisticated exchange of authority based on having a local model of physics, a global model of physics, and a synchronization, we're a good platform to go do that. Another thing I'd add is that if you just booted up GDK and used it naively, you might see like latency, or it feels like latency, but it's actually just a lack of client-side prediction or other pieces, which you can put in place yourself. Later on, we're going to be more transparent about benchmarks once we've done a bit more optimization, but basically we don't add any additional overhead to just making a regular multiplayer game. Not really in the context. In fact, we reduce it in some cases because the server is no longer doing everything at once. And that's one final point, which is if you just have a single instance of an engine and you want to use that for a multiplayer game, there are a lot of reasons why we're still a great solution for you.
Yeah. Actually, on that point, we talk a lot about using lots of servers on the back end, and that kind of often isn't needed for games. Even just offloading the game networking from that server to our runtime gives you enough boosts where you can do far more just with that single box.
And like final on that is like Rob mentioned metagames, and we're going to be more public about it later in the year. But one of the things we'd like to do is to have more of a sort of metagame engine almost, where you can start to answer questions like, how do I organize my game and its structure? How do I do like people moving seamlessly between deployments? How do I ask questions of deployment? Like matchmaking is a very reductive thing compared to where games are really going. And we want to be able to use what we've invested in for 5 years to build an infrastructure that lets you kind of add those pieces on top. Destiny
Time for one more.
Final question?
Final question. Yeah. Who wants to do it?
Excellent. We've answered every question everyone has in the world. Brilliant. Thank you all so much. Please do come and say hi. We have a booth, and we'll love to get to talk to you and talk more. Thanks.
Take care, everyone.